So here, the 17.5 times 176 is 3,080. So the sum of the terms from 3 to 173, all these 35 numbers here, this dot dot dot, there's 31 numbers missing here because I only see 4 of the terms. I see the first one, the second one, the third one, and the 35th term. But it's unimportant what the numbers are in between because the formula only calls for the first term, the last term, and how many terms I'm multiplying. All right, so let's do this, the second one. All right, I'm adding 10 terms together, so n is 10. I need to know the first term, so plug in 1. 7 times 1 minus 2 is 5. I need to know the 10th term because I'm adding 10 numbers together. So the 10th term, 7 times 10 minus 2 is 68. So these are the only 3 variables I need. I need to know how many terms I'm adding together, the first one and the last one. So I take the number of, following the formula, the number of terms divided by 2, and then I add the first term plus the last term. Well, 5 and 68 is 73. 10 divided by 2 is 5. 5 times 73 is 365. So the sum of the 10 terms of this sequence, starting with 5 and ending with 68, adding the 10, these 2 plus 8 more numbers, adding them together, I get a total of 365. Okay? Now the next one, I want to add this sequence together. I want to add these numbers together, starting with 4, 7, 10, some numbers missing, and then the last number is 40. The last number is 40. So I need to know the first term. The first term is 4. The last term is actually 40. I changed that. It's 40. The last term is 40. So the first term is 4. The last term is 40. But I need to know how many terms I'm adding together. I don't know that. So how am I going to get to figure out how many terms I'm adding together? That's where this formula comes in. I need to solve for n. I need to know which number term is 40. I know 4 is the first, 7 is the second, 10 is the third, but I need to know which number term is 40 so I know how many terms I'm adding together. So I'm going to plug in 40 here. I plugged in 40 here. I'm going to plug in 4 for A1 plus n minus 1 times the common difference. Well, the common difference, 7 minus 4 is 3. So subtract 4, 40 minus 4 is 36. So 36 equals n minus 1 times 3. Divide 3. So 12 equals n minus 1. Add 1, and n is equal to 13. So now I have all the information I need to find the sum. So to find the sum, using this formula, I take the number of terms, 13, divide that by 2, 13 divided by 2, and I'm going to add the first term and the last term, 40 plus 40. So 13 divided by 2 is 6.5 times 44. 6.5 times 44, 286. And there's my sum. Let's try the next one. I want to add 52 plus 50 plus 48 plus dot dot dot, some numbers missing, plus 8. So the last number of the sequence is 8. The first one is 52. So A1 is 52. The last number, AN, is 8. I don't know how many terms there are. I need to know n. So that's where this formula comes in. I'm going to plug in 8. I need to know which number term is 8. So 8 equals A1, which is 52, plus n minus 1 times the common difference. What's the common difference? Well, these numbers are going down by 2. So the common difference is negative 2. So let's solve for n now. Subtract 52. 8 minus 52, negative 44, equals n minus 1 times negative 2. Divide by negative 2. I get 22 equals n minus 1. So n is 23. So 8 is the 23rd term of this sequence here. So now I have all the information. So to find the sum, I'm going to use this formula. Number of terms is 23. Divide by 2 and add the first term and the last term. 52 plus 8 That's 60. 23 divided by 2 is 11.5 times 60, and that multiplies to 690. So there's the sum. The sum of these numbers from 52 to 8, let me move this over, from 52 to 8, all these 23 numbers, the first one's 52, the last one's 8, these 23 numbers add up to 690.